Alright, Algebra, I have gone over time on 3 of the videos in this chapter, so I promise the next 2 videos are going to be nice, short, and clean, and they won't drag on. Okay? Exponential growth functions are going to be using this really interesting function here, y equals c parentheses 1 plus r raised to the t. Seems a lot more confusing than it is. Y is going to be the value you're looking for. And that could be anything. Could be population, could be amount of money, could be all kinds of things. C is going to be your initial, or what we call the starting value. Your R is going to be your rate of increase as a percent, and your T is time. And frequently, your T is going to stay as time as we go on. So let's show you what we mean here. So it's pretty sweet catfish here. Did you know that newly hatched catfish on average weighs about 0.06 grams? During its first 6 weeks of life, it grows by 10% per day. Create a model of the situation. So we have to figure out our values. So our C value is going to be our starting value, which is the 0.06 grams. Our R, our increase, is going to be 10% or 0.10, okay? And then our time is going to be 6 weeks, so 6. So if we looked at our equation, y equals C parentheses 1 plus R raised to the T, we go y equals 0.06 parentheses. Now we go 1 plus 1.1 or 1 plus 0.1. There you go. It's easier to write it. So I get 1.1 in here, and it's raised to the 6. And now all I do is I take my calculator, and I go 0.06 times 1. Well, I should probably put that in parentheses. Times 1.1 raised to the 6th. And I get 0.11 y equals, and I have to put a label on this, and I was looking for weight, so it's 0.11 grams. And that's it. That's the whole problem. Now, if we were asked to graph the situation, it says create a model, that could mean graph. We take the t value right there, and we remove it and leave it as a regular t. So we would do just like we had done with linear equations. We take out a number, and we leave it, and now we're going to write x instead of t because we're graphing. And so I go zoom standard. And after it decides to graph it, we look at the table and find out what happened here. And it looks like the reason why this isn't working is because it's still so small that we have to zoom in. Oh, and now we can start to see it. And I'm going to zoom fit here because it's not working. There we go. And now it's starting to look like an exponential graph as well. Okay, how it's curving up to the line. It's a hard one to visualize. Okay, but I could set, let me pause and get a good window here. Alrighty, so I got the graph here. And so you can see it's a hard one to graph because the numbers are small, but eventually that catfish starts getting real big if we create the equation. Anyway, though, we can move on from here and work on the next one. I want you to pause it. I don't want a graph, but I just want the answer to the problem. So we're back. So for this one, we have y equals c parentheses 1 plus r raised to the t. So the c is going to be 800. The r is going to be 0.03. And the t is going to be 6. So we get y equals 800 parentheses 1.03 parentheses raised to the 6. We get out the old calculator, and we go 800 parentheses 1.03 raised to the 6th, and our answer is 955. So Jordan left his thing in for 6 years and got $155 out of it. Doesn't seem like it was worth it, but, what do you do? Okay? So now we're going to be working with some baby mice. You buy 20 mice for Mrs. Chase's science class. If those mice triple in population every year, what is their population after 4? So the key word here is going to be triple. We got to figure out what that means. So the C value, the C value is going to be 20. Now the R, here's where it gets hard. So in this y equals C1 plus R raised to the T, if it says the word triple, this whole thing needs to be 3. If it says the word double, it needs to be a 2, the whole term. Therefore, the R here, if it's tripling, has to be a value of 2, or what we call 200%. So if something has an increase of 200%, that means it triples. Has an increase of 100, it means it doubles. Okay? And the T is going to be 4, but in parentheses, it'll stay as a T because it says the word, or says the word graph right there. So there are 2 equations we're working with. Y equals 20, parentheses, we want this to be a 3 because we're tripling, raised to the T, but we're looking for T equals 4 at some point. So we got to make our graph. So we get T, Y, we're going to make a table. Okay, easiest way to make a table is just simply to go start at 0. So I'll start with a 0 value here. That means this is y equals 20, parentheses 3 raised to the 0. That makes this whole term 1, so this is 20. And we know it triples every year. So 1 has to be 60. 2 has to be 180. 3 would have to be 540, and I'm doing that just by tripling. And 4 would have to be 1,620. Okay, so there's our answer. It's 1,620 mice. The graph, we have to just sketch, because we obviously can't be exact with exponential functions. So this one would look something like this. Let's say these are going to go up by hundreds. Okay, so 20 would be down here. 60 would be here. 180 would be here. 540 would be right about there. And 1620 would be way up there. So our graph would look like that. And all exponential graphs have to look like that, where they shoot up like something like that. Okay? Or they obviously can go down like that. So, have you tried this one on your own? Let's see how you did. So our equation should have been y equals 25, 1.15 raised to the t. So we have t and y. And so for this one, I'm going to use the tabler on here. So that's what your table should look like. Now, the population in 2015, so if 2010 was 0, then 2011 was 1, we'd need 5. So the answer should be about 50, just around 50. Okay, and then you would have to graph it. So let's go zoom standard. We're going to have to zoom out. There you go. Your graph should look something like that. Alrighty. Here's your assignment. So we have 2, 4, 9. So you need to get 8 right here. And you have 2, 4, 5, 6, 7, 8, 9, 10 here. So you have to get 8 right there. Good luck.